Afternoon or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, please know you'll be able to watch it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we will get to as many as we can near the end of today's webinar. Okay, with that, we'll go ahead and kick off today's webinar, which is how online retailer residents scaled DevOps with AWS and CloudShell Colony. Our speakers today are Maya Verlerner, who is CTO at Quali, Pavel Eliav, who is head of DevOps at Resident, and Kevin Wall, who's solutions architect at AWS. Welcome to you all. Thanks for joining me today.
Hi.
Hey.
Yeah, great. I know, Maya, you're going to kick us off with a conversation, so I'm going to put myself on mute and let you get right to it.
Okay, thank you. So let's get started, and let's begin with going over our agendas for today, which is really interesting. We're going to start with talking a little bit about digital transformation and how it's changing the world, and about application environments being a bottleneck for the digital transformation, and how environment as a service can help with this challenge. I'm going to do a little demo of an example for environment as a service and adopting this approach. And then Pavel is going to tell us about residents' DevOps goals, how they use AWS and CloudShell Colony to scale DevOps and their vision. And finally, Kevin here is going to educate us a little bit on Kubernetes on AWS and about Amazon EKS. Then we'll get to the questions. So I think we can get started. So digital transformation is changing the world, big words, but it's actually kind of personal. I know that I personally, with all my interactions with any businesses that I buy products from or use their services, it's all becoming very digital. Now I can give you an example. I am pretty obsessed with renting things. So I have this subscription with a company called Rent the Runway, and I rent clothes from them. About 2 days ago, I get a delivery from them, and the garment is damaged. So I'm perplexed, don't know what to do. What do? I go to the app, of course, and I look for contact help. I find the link, click on it, and I get an error 404 page. Now I'm furious, right? And so this is a typical customer journey that I was telling you about. It's typical for me, and it's 100% application. It's all around it. Nothing, at no time in this journey I was speaking to anyone from this company. And this is digital transformation. It's the fact that all our interaction and our entire experience is becoming sometimes 100% digital, and the center of the business is becoming the application. So it's not surprising at all that companies that a few years ago were worried about where their products go on the shelf are now thinking about how they can hire hundreds and thousands of developers, and about DevOps and about applications. And applications, when you think about them, they're not some virtual imaginary thing that just floats in the air, right? It's some binaries and images that are deployed on infrastructure, which means that getting access to application environments becomes a very big deal when you're doing digital transformation. And it very often becomes a bottleneck, because the people that you see in this diagram on the left could be any stakeholders, let's say the application teams, right? They are thinking innovation. They are thinking about introducing the new features and capabilities that will make it a delightful experience for me, and they want to get it fast because it's a competitive market. But in order to do that, they need access to application environments to develop and test and to release. And then they sometimes need to go through a team of other people that are responsible for the infrastructure. And these people sometimes slow them down. And it's not because they're bad or because they like being slow. It's because they have a different set of concerns. There are concerns about things like getting unexpected bills and not being able to explain them. They are concerned about getting passwords to public repositories in the source control. They are troubled about innocently uploading sensitive IP and customer information to public machines, things like that. And they are rightfully concerned, but sometimes it causes a bottleneck. And then what we see happening sometimes is that the stakeholders on the left say, well, that's too slow for the business. We need the business to be running faster. And then what would happen is what we call shadow IT. So some people get uncontrolled direct access to infrastructure. And what it means is that all these concerns that I was talking about, they either become their responsibility or we don't really know who's responsible for them. So if we summarize the challenges that we see, then we have 3 areas. One of them is on the innovation side, and that's for anyone developing and testing and supporting and doing operations. How do I get environments fast? How can I not wait for environments? And how can I not worry about all these horrible things that I may be doing? And the people who are trying to get these things to work at scale, which is mainly DevOps, it becomes a question of how do I offer self-service? And how do I scale this? And even if I start automating everything and build it to be automated, how do I then make sure that I can maintain it and I can troubleshoot environments and make sure that it actually can work not just for 1 or 2 people? And then we have the third area of challenges, which is the responsibilities that we talked about that are very important. How do we keep that under control despite being flexible and fast? How do we make sure that cost and security and compliance doesn't really get out of control? And I'm going to talk about an approach for balancing these 3 needs and making sure that everyone gets what they need. And this approach is called environment as a service. And at the center of it is the environment. Now, I'm sure everyone knows what a development environment is. I'm sure you know what testing environment means. I'm sure you know what a production environment means. And this is exactly it. It's the combination of components that you need to get a job done. And environment as a service is about blueprinting or creating a template that represents this environment and all these components so it can be used for automation, for achieving speed together with control. And all the components that we're talking about, it's not just the application, right? It's never only our application. It's also some third-party applications and services that you're using. Could be logging and monitoring tools, could be development and testing and security tools, could be tools that you use for data virtualization or for subsetting data. And all of this is deployed on infrastructure. And this infrastructure could be anything, right? It could be a bunch of technologies. And not only could it be a lot of things, it's also kind of moving on us. So technology keeps evolving and we start talking about new things that we can do. So the nice thing about this approach and about environments is that environment is not at all about any single technology. It's by definition, potentially several technologies. And it's really focused on the business need, right? It's this type of container or bundle where you put in everything that you need so that a person or automation can really get the business moving. Let me explain how it looks like from a DevOps perspective. So if we look at the CI/CD pipeline, and we're probably driving it with some system like could be Jenkins or TeamCity or Circle CI or whatever tool we're using, we keep using these environments for all the different stages in the lifecycle. And I've been in automation for about 12 years. When I look at this slide, I think about one word, and that's reuse. I see this environment coming again and again and again. It's always our business in it. So there are some shared components, and this is a great opportunity to achieve more value from automation by reusing components. And this is exactly what we can do, where our goal is to get to production environment. And actually, the more the other environments can look like production environments, we would probably be able to get the business to move faster with high quality products and better time to market. And from a process perspective, it would look like this. So we have the before image that I showed you before, and what we're trying to achieve with environment as a service is a digital transformation for application environments, which means that our stakeholders, the application teams, the developers, the people who do testing and security and operations, they get access to blueprints. And the blueprints of environments become the entity that we put all the controls on. And once we do that, it becomes more like an easy pass than actually waiting to pay cash at the toll. You just go as fast as you can, and the controls are applied as you go. So we can make this team an enabler for innovation and not a bottleneck. So I can take a look for a minute on the benefits of environments as a service, because this is a bit of a different way to look at it, right? We usually look at technologies. We're thinking about automating pods or instances or containers. And looking at it from the environment perspective kind of changes the way we do things. And one of the main benefits of it is that we start looking at our automation as something that represents a business need. So it's abstracted from the technology, which means the way we do automation cannot rely on any specific technology. And this is very important if you're trying to build something that's a little bit future-proof on the technology front, knowing that if, yesterday you were doing instances and now you want to move to Kubernetes, and tomorrow maybe some of your environment's going to be serverless, this approach is still going to work. There's also the scale. Once you have this blueprinting mechanism and it's standardized, you can really start thinking about smart ways to reuse components in the automation across the value stream and not limit that to specific silos. And a third aspect is control. Again, because we have this blueprint entity, and now we can put a lot of the control aspects of it. We can make sure that it's compliant. We can make sure that things are done in a secure way. Everything integrates with all the security mechanisms that we have in place, and that we can also make sure the costs are under control, and we can explain everything that we're doing. And the fourth thing, which I think is extremely interesting, is that we put this context around the infrastructure that we're consuming. And instead of looking at it as a bunch of servers or containers and networking, we give it a name. And the name is a business reason. It could be something like the production environment, or it could be performance testing environment. But we know what we were using these 5 instances or 500 containers for. And this is becoming gradually more and more important. And this is an automatic way of collecting this data. So I want to show you a quick demo of how we implement those general ideas that I was talking about so far. And I'll do it with CloudShell Colony. What I'm going to show is 2 of 3 steps. The first step in working with CloudShell Colony is creating an account and connecting to the cloud provider, in this case, Amazon. Second step, very important, is creating the blueprint. And blueprinting the environment is, this is a critical entity, right, the blueprint, because everything that has to do with reuse and automation and governance and applying all the controls that we talked about is done in the blueprint level. But once we have this in place, then we can start thinking about how we want to launch environments. And it could be either from the self-service UI or from ChatOps, or it can be from the CI/CD pipeline using plugins. So there's really a world of opportunities here to use environments all the way from development to production. Let me quickly move to Colony, and I hope you can all see the product. So this is an example for environment as a service. And what you don't see here is the creation of account. And I've also already connected to my Amazon cloud account here, which is a standard AWS procedure. But now that I have it connected, I can start thinking about the blueprints. So I have the blueprints area here, and let me drill down into it. And you can see that I have a list of entries of blueprints. Of course, behind the scenes, it's YAML files. They are source controlled. You can see here, in this case, in GitHub. But it really helps to see them in a more graphical way here. Because this is where we want to apply things like role-based access control and decide which of the blueprints can be published to users, and put some policies around how these blueprints are going to be used and by whom. Let's drill down into one of these blueprints. And if anyone, really wants to see YAML, that's fine. I'm going to switch for a second so that you have this comforting view of YAMLs. But I'm going to go back to the designer view because sometimes it's easier to show it visually. And I think one of the unique things about the blueprints specifically in Colony is that it abstracts applications from infrastructure. And this is super important. In this case, for example, we have in our application, it's called in this demo Promotions Manager. And we have three components. We have the UI service, we have the API service, and we have the database. And this is our business, right? This is going to pretty much be repeating itself in a lot of our blueprints. And what we do here is we abstract it from infrastructure. So infrastructure, you can see here, is a separate tab. So in this blueprint, these three applications can be deployed on a T3 medium AWS instance, but the same three applications can be reused and they can be deployed on three containers in another blueprint. And that makes it very reusable and very powerful. So now that we have our blueprint, next question is, how do we use it? And we have two options. One is in this area of sandbox environments. The other one is production environments. I'll go to sandboxes quickly. And sandboxes are transient environments, usually for pre-production, and they have an end time, so they're going to finish at some point. I can start a new sandbox, show you how it's done. The first thing you see is a catalog, right? Because we talked about self-service, and I can see all the blueprints that I have access to. I can choose one of them. I can click on set parameters here and give it a good name. Let's say I'm running some tests, and I need to do security testing. And I'm going to use this for 2 hours. This is a little gray component, but it's actually extremely important because we want to make sure that any pre-production environment that goes up also goes down responsibly at the end of the activity. And once I'm ready with all the input parameters, which make the blueprints further reusable, I can launch my sandbox environment. I'm going to do it right now. Prepare for a party, Kevin. Yay. Always a pleasing moment. Okay, and now I'm gonna open my sandbox. So if you're asking yourself what the party was about, it was about launching my environment, and when it ends, I'm gonna get one environment that is about what I need to do, security testing, and it's going to be ready. And how we're gonna do that is we're going to create an infrastructure, prepare the artifacts, networking, deploy all the applications, and then make sure that we have one working environment with all the components in it. And I don't have enough time to wait until this is done, so I'm going back to my sandbox environment area, and you see this one's launching, but I have one because I'm a very responsible person. I already started one earlier. And you can see I drill down into it now. And if I'm doing security testing, or if I want to check a typo in the UI, it doesn't really matter. I want to check something in my application. I don't care about the environment, right? I care about one thing. Where's my application? And it's here. In the quick links, I can just click on it, and you see this is the promotion manager. This is the demo app. It's a website. I can start running my tests. I'm going back to the environment. So there are a lot of additional capabilities that can be added when it comes to troubleshooting and some cool things that I can do in pre-production. But I think it's also important to look at the entire process. So after I validated everything on pre-production environments, it makes complete sense to use the same automation that is working and validated and deployed to production. And so we have the production environments area. And you can see here that it is a separated area from, I think, obvious reasons, not only in the UI, but it could also have separate repositories and could be also a separate account in the cloud provider. And let me drill down into one of these production environments that I'm managing. And production environments, of course, are a little bit different from pre-production environments. They don't have an end time. You just keep them there and you upgrade them as you go. So in this sense, when we think about the role of environment as a service in deploying to production, it's actually three things. The first one is deploying the new green production environment, making sure it's okay. And then the second step is exposure. So it's controlling the load balancer and making sure that traffic goes from our existing blue environment to the green environment. And this is done with this API or UI, so I can go all the way to 100%. So everyone sees the new green environment, or I can roll back quickly to 0 if that doesn't work. And finally, when I go to 100 and everything's okay, I don't want to have 2 environments running for nothing. So I can go to step 3, which is complete. And this step tears down the blue environment, and it makes the green the new blue. And then, of course, the process goes on and on. And I showed you this from the UI. Obviously, many times it will be driven either from the API, Pavel will talk about that, or also from CI/CD pipeline. So I'll just show you, examples for some integrations that are seamless in this product. So that's a good way to go at it. So I'm going back. I hope this gave you a nice, picture of what environment as a service in general can look like. And I'm really going to see how, how Resident really did that and turned some of this vision into reality using AWS. So over to you, Pavel.
Hey, Pavel, are you with us?
Sorry about that.
Hey, there he is. Hey.
Hey guys.
Pavel.
Sorry about that. I got surprised. Okay, so I'm Pavel. Hi guys. Maya, please take me to the next slide. Resident is a startup in the e-commerce arena. We have, I think, over 12 brands under Resident right now, and we basically we're here to revolutionize the home furniture space. We have already 3 leaders in the bedroom area, and we are growing more and more brands for other spaces in the house. And it's important, and I will explain in a second why. We have about 200 employees, I think that even more, located in 15 different locations across the globe, I think 4 countries, maybe 5. And we are constantly growing both in human power and brands and services that we supply. Let's move to the next slide. So when I just came in, it was pretty simple. We had few brands, we had some kind of similarity between them, and the pipeline of going over this process of CI/CD, if you want to call it this way, or the environments of QA, staging, dev, and production was pretty much straightforward as in any other company. But once we started getting some traction and we started growing our brands more and more, we got to the point where we had to start thinking about how we want to handle this. All of a sudden, we could have an entirely new brand which isn't similar to any of the other brands we had, and we have like 100 people working on different aspects of it. And on another day, we could have all of those people and more working on 5 different brands. So having one static environment, which is either local or shared between all of those people, made less and less sense moving forward. So the goals, as written here, are obviously support this kind of growth, both in people and brands. The sharing of the environments got more and more problematic as we started developing more services which were specific to specific brands, or we could have, in the same time, deploy some services which were common between all brands. And it made a lot of problems when 2 different teams were trying to test entirely 2 different things on the same environment, obviously. The other thing is that because of that issue, we got into a slower cycle of development. More people had to wait for the environment, more teams got conflicts, and that obviously isn't good for anyone. And of course, we wanted to cut costs. We wanted to cut down cycle times. And what I was interested the most is to have some kind of process behind all of this, because solutions like Docker was obviously like first on the line, but I had the sense that the issue here is not as technological as it's a process question. So I really wanted to find a proper solution. Next slide. Thank you. So what we had is a growing need of scale in each of our environments. So it wasn't as simple as having a bunch of servers for QA, a bunch of servers for staging, etc. We needed a way to properly control the scale, both of the environments themselves, but specific resources in each of them, or just to have like for the next couple of days, 30 different staging environments, which had a lot of common ground, but still enough differences to actually properly test those conflicting changes that we were working on. And obviously, if you are at any extent working with A/B testing and trying to make data-driven decisions, having as many environments as possible before going to production is awesome. So our main goal was to start breaking down the environments, and where beforehand we had development environment as a local one and the QA and staging as centralized environments. The goal was to basically allow any team, any developer have each of those environments for himself, or to share between the team, or to share between multiple teams without causing any delays whatsoever or any conflicts whatsoever. Okay, I think let's go to the next slide. Cool. So Maya showed the UI beforehand, which I really liked, but because our main focus was the actual scale of the environments, I had to find some kind of API and more automated way of controlling it. And I was pleasantly surprised that the API is very, very, very comfortable and full. So I didn't have any issues basically automating all of the operations that we needed. And because we already developed our own bot through Slack, it kind of made sense to expose Colony through Slack instead of only the web UI. And we started as a POC. That was another thing. Like, we didn't want to invest either in Dockerizing everything or having our own fully automated solution, just to invest a couple of months in it and then finding out that it wasn't useful for the actual developers, which is the important part here. So we kind of like gave the ability to the developers, and were hoping for the best, and we were surprised how fast it took off. So once the developers got into our bot, which is very familiar for them, we had a huge spike in usage, and we keep having more and more use cases that we actually developed to support now, because we didn't think that it will be that useful. So in this slide, you basically see that we just go to our Slack bot, deploy whatever environment we need. The next step here is our branch in GitHub, and then the brand that we need to deploy. And within 5 minutes, we have everything set up for us. And on the right side, you can see how this translates basically to the Colony UI. That's it, I think, for this slide. So just to recap a bit regarding all of the information I just went over. So what we had beforehand is people working for some time on their own code and got to the point where they, on one hand, needed to share it with other developers. On the other hand, they needed to share it with project managers or product managers. And obviously, it was eventually had to be tested in the staging, with integrating with everything else. It sounds pretty simple. It gets more complicated as you have, like, basically each brand is an entire new company. So if a normal company usually develops a couple of services under its umbrella, we have like dozens of them, and we keep adding more and more services, more and more use cases on a monthly basis. And the situation that we got into is that we had like hours of waiting and conflicting and taking down those environments each time we had to roll out a big change. So once we switched to this process of everybody can have his own staging QA development environment and share it. Basically, we don't have almost any conflicts anymore that I can think of. And the 5 minutes here is key, because that was one of the things that we needed to make sure we supply for our developers, because in theory, all of this sounds great, but if you have to wait like 30 minutes before you have an environment, nobody will wait. So we reached the 5-minute mark, and that went well. The static environments, we don't actually have one anymore. We have a staging environment, which is like a general thing, which also, by the way, runs on Colony. But the thing is that any developer can have his own staging environment to integrate everything and test it one step before we go even further to the shared staging environment. Increase the development speed is obvious. The access-based control is another key here. We have kind of a united solution, because Quali, CloudShell have their own security solution, which I didn't mention, but it's there and can be very easily managed. And also, it's something that's very easily managed from our side. So we can reach a very low resolution of how many people can use it, how they can use it, for how long they can use it. What else? Cloud utilization. It's actually an interesting metric, because since we started using the environments, we actually have more usage because more people find new things to test, new things to work on, new things to collaborate with other teams. So at least in our use case, it wasn't something that we expected. Like, it wasn't in our focus, and then we just found out that we have so many use cases coming up, and we need to start support again. And scale is awesome. Like, we wanted to have one QA, one staging, one dev, and now we have dozens of them all of the time coming and going. That's it, I guess. Maya? Cool. Well, obviously, as I've mentioned before, Docker and Kubernetes are definitely in our sights. As I mentioned before, we wanted to have some kind of a POC, some kind of a process before we start investing in that area. We have some implementation of Kubernetes, and we almost jumped into it before we actually knew how it will look like. And retrospectively, I have to say it was a good decision, because again, like, the use cases are coming in, we always find something new to do. So now that we have some kind of sense to what to expect, now it makes so much more sense to develop the Kubernetes part of it, because now we know exactly what we are trying to resolve and not generally going into the Docker world and hoping for the best. So I guess we'll talk about it a bit more soon, but it's something that we are going to develop very, very soon. And as Maya said, basically, it's kind of seamless to us because the blueprints are already there, the applications are already there. So we just now need to Dockerize it, and we move forward in the same way. I think that's it about this slide, right?
Yeah, that's super cool, Pavel.
Thank you.
Yeah. On we go to Kevin.
Yeah, thanks, guys. That's a great success story and solution so far on CloudShell Colony and with Resident. So I'm Kevin Wall. I'm a solutions architect here at AWS, and I'm just going to be providing really a brief overview of Kubernetes on AWS, and specifically with our Amazon EKS service. So just a few foundational slides to really before we get into EKS. And this is really building upon what Maya was talking about earlier. And these are, EKS just fits into this story, into these best practices. Certainly not the only piece of it. When we start talking with customers about best practices for building modern applications, we're looking at things like automating your CI/CD pipeline as much as possible. Streamlining your operations with infrastructure as code. And really starting to try to decouple services from some of those monolithic applications by using microservices and trying to adopt serverless technologies. Now, I think probably any modern application architecture discussion wouldn't be appropriate without talking about this monolith versus microservices approach. And we get into these conversations a lot. We have to be careful because sometimes I think these terms start to be a little bit overused. But when we want to look at how to build faster and how to iterate quicker and get an application and a product out, we start to really look at something like microservices. Now, the challenge with that is that it doesn't really apply to every single architecture, and it's challenging to set that up in the very beginning. So monolithic tends to be very simple because you could just do everything and put everything into one place. But when you want to update that and expand that and scale that out, it becomes a challenge. Whereas with microservices, there may be more upfront planning and design work to deploy a microservice application, whether that's a new native cloud-born application or you're moving from monolithic. But the performance and the benefits are seen in the long run, and being able to focus on just a specific service or a specific component of the service as opposed to having to look at an entire application that needs to be updated. And so microservices and containers, not exactly the same thing. These tend to be used in the same context. You can definitely do one without the other, but when we look at a platform like Kubernetes, it definitely facilitates the ability to adopt this microservices approach and use containers. And so we have several services that really help you get started and deploy to move either from an existing monolithic application or on-prem microservices environment into the cloud. We'll be focusing on EKS today, but when we start talking with customers about what is the appropriate one for you, because there's different offerings out there. Some of them really work together well. Some of them are really more focused on just one particular component. And so we get into conversations with what is most appropriate for your workload. And so you may have multiple workloads and use different services for each one. And so they tend to focus on, do you want to have that customization and that certain level of control over your environment, or do you want to be more focused on just being able to push your application out and not be so focused on the heavy lifting components of that? And so we start looking at this, having the ability to manage something yourself versus something that AWS manages for you. And so Kubernetes would fall more into that concept of, and specifically EKS falls more into that concept of a managed service. And so if we look at why did AWS build and introduce EKS? Well, an interesting statistic from the Cloud Native Computing Foundation that many Kubernetes workloads were running on EKS on AWS today. And so, like many of our other services, we take feedback from our customers on how to improve and introduce new services to make their lives easier. And so there was a request to give something more where I could still use Kubernetes and I still have some level of control over it, but you're managing a certain component of it. And so that's where EKS was born out of. And so Kubernetes is definitely not something specific to AWS. It's been around for some time, but it's the key component of the EKS platform. And so just real quick overview, Kubernetes, it's been around for some time. Hopefully you've had a chance to use this, but it's an open source container management platform, and it's really giving you those components to build your applications using building blocks and then scale those applications out. So very high level, that's what's Kubernetes. Sometimes it's like it helps to see what does it actually look like from an architecture perspective. And so when we talk about Kubernetes, it's typically in two different high level categories. We talk about master components and node components. The node components, this is where your actual services live. This is where the applications are being accessed. This is where the users are consuming the applications. And you might have multiple replicas of an application living within multiple worker nodes for resiliency. And then there's this concept of what we call the control plane, which is providing that scheduling and management of the worker node. So making sure that an application is running when it needs to run and at the scale that it needs to run. And then also providing you a API into the Kubernetes cluster so that you can control the overall operations of it. And this is where like your CI/CD pipeline would plug into. There's a common command, kube control, sometimes kubectl, depending on what camp you're in, to access the actual cluster. So now if we look at EKS, it's still Kubernetes, but what we've done from a managed service perspective is we've separated the control plane, those master components, into an AWS managed account. And so your typical like etcd components for configuration state, the scheduler concept, this API to access the cluster, we deploy all that for you in an AWS managed account, and we take advantage of the resiliency that's already within AWS to spread that across multiple clusters of data centers in different regions called availability zones, and then provide you that API to get to your cluster. And then you're responsible for the individual worker nodes. So those get deployed into your account and you have the control over them. Now, we do give you some guidance and help you get started quickly with developing and deploying worker nodes. And I'll talk about that here in a second. But you still have that control over it. So that's that mix of a managed service that we control piece of it, work for the control plane, any kind of patching and issues that come up with it, any kind of paging, any updates to that, we take care of, and so you don't have to. And then just quickly, a piece about how it works. There's what we call an elastic network interface that gets deployed into your account, and that is how we facilitate the communication within the cluster. So just from a very high level, maybe sometimes it helps to focus on a more simple picture: master control plane, master components managed by AWS, and we just provide you this endpoint into it. And so this gives you also the ability to determine how you want to scale your nodes out. So maybe you have a development or a test environment that doesn't need to have presence in multiple availability zones or multiple regions, but your production application, your production worker nodes would need that. One of the other benefits that our customers really like about EKS is that you can now use your identity and access management permissions and roles that you've already defined within AWS to access your Kubernetes API. And so there's a component that we've introduced into the cluster to allow you to use those AWS native permissions to access the API. And then there's the underlying Kubernetes authorization model, the RBAC model, that's still in place to allow you to actually access the cluster. So this is a great feature. This is a really, if you're familiar with Kubernetes today, and this is something that you're already accessing using the RBAC model to access your permissions, when you move this into EKS, you get this advantage of being able to use those roles. One of the other benefits that customers really like is that you can associate our storage services with your containers, so with your individual worker nodes. And so whether you have a need for something like block storage, or you need to mount file shares with using something like the EFS, the Elastic File System, or you have something more of, you have a need to use more something like Windows storage with FXX, there's hooks to allow you to attach our storage services to your individual containers. So I talked about how you're responsible for managing and deploying the worker nodes in your own account. We definitely help get you started. There's an Amazon machine image, we call them AMIs, that is EKS optimized, and it comes with components like Docker and kubelets to really get you started and help deploy those worker nodes quickly. Now, this is an Amazon Linux-based image that fits a lot of use cases, but maybe there's a particular use case that you have for your workload. So you might be running something like financial services applications or AI or machine learning workloads within your worker nodes, and you need a very specific type of instance. And so you have that flexibility to deploy the type of compute EC2 instance that matches up to your workload. And probably one of the really key points about EKS is that it's Kubernetes certified. So as I explained, we're just separating out that control plane from the worker nodes and managing that control plane for you. So, but it's still completely compatible with Kubernetes. If you are, again, comfortable with managing Kubernetes and you have that tied into your CI/CD pipeline, you have existing applications that are running on Kubernetes, those can all be moved into EKS. Okay, so to tie this back to CloudShell Colony and this, and a use case like at Resident, you think, okay, so great, AWS is managing this control plane for me. How does this really fit into the bigger picture? And it's just one part of it. So back into, if we look back some of what Maya was talking about earlier about this whole process of getting from initial development into production. I have this concept of a developer who's pushing code out into a code repository, and this could be, this could be GitHub, Bitbucket. Really, in this context, we're really focused on being able to develop quickly within a containerized environment. And so I'm pushing my code out into a code repository that typically would trigger some type of code pipeline because there's new code updates. A new container image needs to be generated. That container image needs to be stored in some type of container repository, which is going to trigger an update into the Kubernetes cluster, and Kubernetes is pulling that new image in. So EKS is just one piece of this. So that's really helping you with from that management perspective and not having to worry so much about the control plane. But you still need to figure out how your application fits into EKS and how you're going to deploy your application through this hopefully automated CI/CD pipeline. And that's where we really rely on our partner ecosystem to provide that additional layer on top of EKS. And CloudShell Colony is a great example from the CI/CD perspective. There's a number of partners from foundational to introducing monitoring and logging, helping address specific advanced networking scenarios. And so I know Resident, when the interest in EKS is great, but they wouldn't just be able to use EKS alone. They would need to rely on a partner like Quali to really make it work in their across their different environments and really help them automate their CI/CD pipeline. So hopefully that's a basic introduction for you into EKS. It is certainly not a deep dive. The platform is big, and there's a lot of features to it. If you're really interested in it, check out our EKS product page. There is a wealth of materials on our AWS YouTube channel on everything from security and networking and logging and monitoring. And then just finally, there is a self-paced EKS workshop site. So if you're really interested in getting your hands on it and really understanding what it is and how it works, check out eksworkshop.com. It takes you all the way from deploying all the way to managing and securing your EKS cluster, and really gets you the experience that you would need to start with it in your own environment. Okay.
Great. Thank you, Kevin. And okay, our conclusion is really short, guys. I think we understand that, right? Environment automation is great. There are different ways to do it, but you really should, whether it is to be future-proof with technology and to make sure that you're thinking about the business need and not just about how cool the technology is, even though I think all three people on this specific webinar feel that, it's fun to play with the cool stuff. But it's good to create things that are a little bit more about the process and about the business and really making it faster. So I think with this, going back to you, Charlene.
Yeah, absolutely. So we're about 8 minutes to the top of the hour. So we have a few minutes for question and answer. If you do have a question, please go ahead and use your GoToWebinar control panel and submit your questions, and we'll get to as many as we can. Let's see, our first question here is, I think, Pavel, this one is for you. What made you decide not to develop it on your own with open source tools? And what was the biggest challenge in adopting this approach?
That's a great question. I have a crying baby on my right, so I hope it won't interfere too much with the answering.
You mean you have a life? I don't understand that.
So let me know if it bothers a lot, and I will try to figure out how I move away.
Okay.
So back to the question. It's a very good question, and it was something that I actually was thinking about quite a bit on my own. The decision actually came from a very operational perspective, meaning I wanted to make sure that we don't, as a company, we don't go too deep into a solution that we are not entirely sure that we need. And what Colony helped us to do is to have a framework very fast in an operational manner. So our initial investment was quite short. We didn't have to go for weeks or months of developing something on our own. So within a couple of weeks, we already had a working POC, and we took it live, right? And a couple of weeks later, we had like a dozen more use cases that we needed to develop. So in general, I'm usually more inclined to do things on my own. In this particular use case, I was very well surprised how well it worked. And the other thing is that it's always good to work with experts, right? So I don't really like to let go, but when we started working on this, it wasn't like, this is how you do it, right? It was Colony and ourselves cooperating, right? So we built it to fit our needs. So bottom line, it saved us a lot of time, a lot of wasted resources in case it will fail, and a lot of support from their end to our upcoming use cases. I hope that answered it.
Okay, all right, great. Thanks very much for that one. Kevin, I believe this next question is for you. Is EKS leveraging AWS Fargate behind the scenes?
That's a good question. So EKS and Fargate are separate services. Fargate is more of the very managed container. So as opposed to having the control of the individual worker nodes yourself, it's much more of a managed service. But no, EKS and Fargate are different services. Obviously, they're based on containerized applications and services, but it's not the EKS or Fargate under the covers, so to speak.
Okay. Okay, I have another question here. I don't know who it's for specifically, so I'll just throw it out to all of you. Is having a reliable, powerful, and stable internet connection an absolute prerequisite for environment automation?
Maybe this one is for me as the environment. Yeah, so I think the answer is no. And Quali has has been doing environment as a service. We have a few products for doing that, and in one of our products we really focus on enterprise environments where sometimes from different reasons it doesn't have to be stability, it can be security, right? If you're doing things for military or government, and you really can go to public cloud necessarily, and you need to work and your environments are on-prem. And in this case, of course, you can still automate environments. You can do environment as a service, and you can stick to the same principles, only that you don't get the luxury of having Amazon take care of the dirty work, right? You have to do it yourself.
Excellent. Okay, I think we have time for one more question here. Kevin, I think this one is for you as well. Do I still have the ability to upgrade my Kubernetes cluster if AWS is managing it with EKS?
Right, so obviously the worker node component of it, you have the control over those components. In terms of the control plane, as I mentioned, AWS is managing that and patching it for you, but we're keeping in line with current Kubernetes cluster versions. So you have 3 different versions to choose from. We want to make sure that we're keeping current with it. But you select when those updates get applied, because this is very important for when you want to test something like an update to the API and make sure it doesn't break anything. We will actually perform the upgrade, but you tell us when it works for you.
Excellent. Excellent. Okay. Let's see. I think we could slip in one more question, and then we'll close it out. After I deploy an environment, is it possible to set up automation to deploy applications by themselves?
Yeah. Most definitely. That's a big part of it, right? If you handle only infrastructure or you handle only applications, that it's only half of the story, right? The thing is, you need to take care of everything that's in the environment, and that includes infrastructure, and this is why infrastructure as code is brilliant, but it's also applications, and this is why application deployment automation is brilliant. You just need to put them together.
Excellent. Okay. Well, we're about 2 minutes to the top of the hour, so unfortunately that's all the time that we have for Q&A. If we didn't get to your question, I apologize. Just ran out of time, but please know that these fine folks will be getting a copy of all the questions. So I'm sure somebody from their organization will be more than happy to follow up with you offline. Also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to listen to it again, you'll have the opportunity to do so. We are going to be sending out an email post-webinar that contains a link to access the webinar on demand. So you can always just use that and to access the webinar. The webinar is also going to be living on the DevOps.com website. You just go to DevOps.com/webinar. Click on the on demand section and it should be right there waiting for you. And while you're there, please take a look at some of the other webinars that we have both upcoming and on demand. Hopefully there'll be 1 or 2 that pique your interest. Maya, Kevin, and Pavel, thank you so much for your time today. Great presentation. Really appreciate it.
Thank you.
Thank you.
Also want to thank the audience for joining me today. And this is Charlene O'Hanlon and I am signing off. Have a great day, everybody.
Bye.
Bye-bye.